The first crystalline structure I'm going to discuss is simple cubic. As you see, the unit cell of simple cubic structure contains atoms at all the corners of a cube. And what is a unit cell? The unit cell is a representative of the entire lattice and is regularly repeated throughout the crystal. In the simple cubic structure, each atom at the corner of the cube is shared with 7 neighboring cubes. So unit cell contains 1/8 of an atom at each corner. Cesium chloride is an example of simple cubic structure. The importance of unit cell lies in the fact that we can analyze the crystal as a whole by investigating a representative volume. From the unit cell, we can find distances and forces between nearby atoms. Also, we can calculate the fraction of the unit cell volume which is filled by atoms and relate the density of the solid to its atomic arrangement, which I am going to calculate right now. On the left side of the screen, you see the 2D representation of the unit cell. You are looking at it from the front side. Spheres represent atoms at the corners of the unit cell, which is a cube of side A. The radius of each sphere, or I'd better say the radius of each atom, is r. Therefore, the distance between two neighboring atoms is 2r. Since the cube sides are perpendicular to each other, we can calculate distance x by using Pythagorean theorem. So distance x equals 2 times square root of 2 times r. Now I want to calculate the maximum fraction of unit cell which is filled with atoms. This is also referred to as atomic packing factor or APF. The result gives us a better understanding of how dense a simple cubic structure is. Since the unit cell contains 1/8 of an atom at 8 corners, I can say the total number of atoms for each unit cell is 1 atom. The volume of each atom, which is the same as the volume of each sphere, is 4 divided by 3 times pi times radius r to the power 3, and I multiply this number by 1. And why 1? Because as I have just explained, the total number of atoms per unit cell is 1. This is the numerator of the fraction. The denominator of the fraction is the volume of the unit cell, which is a cube. The volume of the cube is one of its sides to the power 3. So it would be a to the power 3, and from the left-hand side picture, you see that a equals 2 times r. So the unit cell volume would be 2r to the power 3. If I simplify this fraction, I will get the result of pi divided by 6. In future videos, I will show you how to simplify algebraic equations by using MATLAB.